Good morning.
Good morning, Pastor Clark.
That will not endear you when we take the test. So we had beautiful sunlight this morning, didn't we? Someone that's keeping track might say 32. I think there's been more than 32. There have been more than 32 lessons. I did 7 lessons on creation a couple years ago. And so this is actually lesson 39. Hard to believe that. The glory of God in creation. I'm going to talk about day 1. Now, someone will say, you did this lesson 2 years ago. And my response is, yes, I've added some material, dropped some material. And repetition aids learning. Repetition aids learning. Repetition aids. So if when I'm done with the class, you go, that was just a repeat, you can get a refund from Ray Lee after class. So just go see him about it. And this, as I think, is March 17th. And I had to email Pastor exactly what was our emphasis this year. Discipleship. I want to encourage the disciples because we are bombarded on every side by the concepts of evolution. We absolutely are. So when I did the 7-part series, which I'm not going to do, the next 3 weeks is going to be a little bit different. I talked about light, which is what God created on day 1. And then I talked about water, plants, the heavens, birds and fish, creatures and man, and then God rests. And I talked about evolution. So this week I want to talk about light. Wouldn't it be interesting if someone would develop a method to keep the sun out of your eyes when you're at a ball game? It seems to me like perhaps someone is wearing their hat backwards. Genesis 1, 1 through 5. How many have seen the Northern Lights? You can see them sometimes in Indiana in the summer. If you go north, you will see them more predominantly. And if you go quite a bit south, you can see the Southern Lights. So we do not apologize. We believe the Word of God from the first word to the last word. In the beginning, God created the heavens and the earth. The earth was formless and void, and darkness was over the surface of the deep. And the Spirit of God was moving over the surface of the waters. Then God said, let there be light, and there was light. Day 1, light. That's it? You don't understand. You don't understand the complexity of light. And God saw the light was good, and God separated the light from the darkness. God called the light day, and the darkness he called night. There was evening and there was morning, one day. By the way, to me, Scripture's pretty plain. Day 1, the first day. So I see this word good, and what happens when I get these lessons ready? I get off on these rabbit trails, and I do this all the time. So I spent some time with the word good, and I'm thinking suitable, trustworthy, fitting, appropriate. There must be something interesting about the word good, perfect, unbelievable, incredible. Those would be the words that I would use. God used the word good. So I looked that up and found there are 462 occurrences of good in the Bible. It's just good. It's not any of those things. It took man to discover the unbelievable complexity of light. So, could we have the lights turned down a little bit? Could we have the lights turned off? And I would like a volunteer if I could have one, because I'm going to help you create light up here. I'll do it if no one volunteers, but the kids are gone. The kids are gone. No one want to do this? You all? Good. Come on up. The first light we're going to create will be the candle.
Right now?
Please. Very good. He knows how to keep it from going out. Now you may want to cover your eyes like you do with the solar eclipse that's coming up next month. Is that blinding or what? That's incredible. All right. We got a couple other forms of light here. Battling flashlights. I think my microphone picks that up, doesn't it? Huh? How about hitting that button down there on the, somebody asked me about, yeah, right in the middle there. I was trying to plug some of them in and keeping the lights on going. All right. So here's another way that we're going to create light. You're going to need your goggles. I'm going to get, and that's the cool thing about science. I mean, I can demonstrate this stuff and sort of keep your interest. I mean, what can you do in Spanish? Cinco. All right, great. Cinco. When I'm around Hispanic people speaking Hispanics and so on, I say mucho quite often. It means a lot to them. I know, you got to stay awake in class, don't you? So this one is interesting. I think we're going to uncreate your light there if you want to blow that out, Joey. Thank you, Denny, for bringing the blowtorch. I tried this before, and it was kind of amazing that I couldn't get it started with a match. And I ask you not to look directly at the magnesium when it burns. Magnesium is an element. You're going to hold this like this, and you're going to put it in the flame. And you got your goggles on there. All right, let me see if I can get this started. Danny told me to do this, and do this, and then turn it up more. Okay, wait. Let's turn that light off. Do not look directly at this. Yeah. Okay, it is. Do not look directly at this, but avert your eyes a little bit when this burns. If you could, hold it over this pan. Once you get it ignited.
Stick the tip in.
Yeah, yeah.
I'm trying not to look at it.
Oh, well, you're going to have to look at it to get it started. Okay. Somebody says, well, I'll just look at it until I need glasses. Well, most of you need glasses, but... And I see Jake back there put his solar eclipse glasses on. By the way, that is a chemical reaction. I could write the equation up here. Magnesium plus O2, magnesium oxide, blah, blah, blah. Pretty cool, huh?
Yeah.
No, it was hot. And then one last. The little laser.
Okay.
That's the button right there. You got to turn it around. Turn it this way.
Okay. I don't want to get anyone's eyes. I don't know if it's on.
Hit it again. Sometimes you got to hit it a couple times.
You press it 5 times. So. Okay,
There it is. That's a comet. A comet streaking through the sky. The tail is always pointing away from the sun.
I know.
Boy, I got the right person here for this. Wants to play with that.
I use a lot of lasers with the cats at home.
And dogs don't pay any attention to that, do they?
No.
Now, this is really a convenient little laser pointer here.
It's not turning off.
Yeah, you can't turn it off this way. I tried. You got to take out the batteries. We just stay close because I've got another demonstration later on. Thank you. Did I create life? Light. I've been studying creation of life, but did I create light? Did he? Absolutely not. He didn't create light. All he did was use the substances that we have here to, like the batteries in the flashlight, to cause the filament inside the flashlight to glow. However, when you consider somebody like Jonathan Sarfati, who is one of my creation heroes, who has a bachelor's from Victoria University of Wellington, that is in Australia, and a PhD in spectroscopy, that's chemistry, spectroscopy. You could spend an entire life just studying light and not come to the end of it. Just light. We do not create light. We study the properties, we study the uses, how does it help us, and so on. And he gave a presentation over at a Lutheran church on the west side a couple years ago, and I had to get my picture taken with him. A genius, absolute genius. But let's consider Thomas Edison. Have you heard of him? Yeah, most elementary kids have. And when you think of him, what do you think of? The incandescent light bulb, right? Do you know that he has over 1,200 patents? Over 1,200? The telegraph, the telephone, the incandescent lamp. And so here's a model of his incandescent lamp. And he worked on this in the 1800s, late 1800s. So as a teacher, I ask questions. So here's my first question for you. What was inside the experimental bulbs of the 1800s? What do you think? Oxygen, nitrogen, inert gases, mixture of nitrogen and inert gases? Nothing. Okay, with the remotes that you have, key A, B, C, D, or E, lock that answer in. Does anyone use a lifeline? 50-50, phone a friend? Okay, have you figured out what, okay. It is not oxygen. Now, what would happen if you had a filament and you shot electricity through it and there was oxygen there? It would maybe not explode, but it would combust. So that's not good. Did you choose that? Inert gases? A mixture of nitrogen and inert gases? Nothing, or nitrogen? It's actually, this is the kind of question you'd like to have on a test, where 4 of the 5 answers are right. There wasn't just one person trying to figure out how to get the incandescent light bulb working. There were many, and they used a combination of those things. What's in our light bulbs today? It depends on the light bulb, but a combination of nitrogen and inert gases. So, there were 40 people working for him. 40. I got the ideas in his little Menlo experimental lab doing all this stuff. 40 people working for him. 40,000 pages of notes. What's the average notebook? 80, I don't know. So let's say it's 100. That's what, 100 divided into that is 400 notebooks? He tested 1,600 filaments. He finally came up with carbonized bamboo as the filament that would work, and it lasted like 12 to 14 hours before it broke or burned up. And 1,599 boo-boos If Edison attempted to patent the incandescent electric light bulb today, and here we have a picture of one, that little filament, what's it made out of, do you know? Tungsten. A W is the element symbol. Wolfram is the Latin. If he were to develop it today, I need to quote that, 90% of the energy released as heat, only 10% as light. You don't go up to a light bulb that's burning and maybe it just burned out and take it out with your hand, do you? No, it would be hot. It would be rejected, and there's sound in that. I don't know if you turned off my sound. It would be denied by the EPA. Yes, it would. Well, there was sound. Okay. Yeah, there you go.
Is that because it would be dangerous and hot? I mean, it could burn somebody? Is that why it would be denied?
No, it would be denied because it's 90% inefficient.
Oh, all right.
Right? And that's why they're trying to get rid of the gasoline-powered cars. And I'm not going to go into EVs right now. And God said, let there be light, and there was light. So we study the properties of light. We do not create light. We set up circumstances where we can have light, but we do not create it. So 3 things can happen to light when it strikes something. You know what they are? The same 3 things that can happen to an infielder for a Major League Baseball team. I actually used this picture last time. This happens to be somebody from San Francisco, the Giants. So what 3 things can happen to an infielder when a ball comes toward him? You can field it cleanly, it can go through his legs, or it could bounce off of him, right? Those 3 things can happen. By the way, the San Fran Giants made 117 errors in 2023.
That's why they finished under 500.
You know, I don't follow baseball because of all the shenanigans they've done the last whatever, and also because the White Sox are crummy. Sorry, Nat, we're crummy. So, and I am a White Sox fan, sort of. I did look it up. I wanted to know. Last year, they led the league with errors. This particular page said 117 errors. The White Sox are not far behind, down there at the bottom of the list. The same 3 things can happen to light. It can be reflected. What you're seeing right now is reflections of light that's falling on people. People are wearing green. The reason I wore green is all those years, kids would come up, "Where's your green, Mr. Clark?" So I decided, instead of trying to answer that question, I'll just wear green. It can be reflected. When you see somebody that's wearing green, all the light that's falling on them that is not green is absorbed. The green is reflected so that your eye can see it. It can be absorbed. Black absorbs all the colors. And it can be refracted. I'm just going to briefly look at reflection and absorption because the most interesting thing about light is refraction. Oh, I should have said this at the beginning because some of you haven't been in my class before. I'm not a preacher. I'm a teacher. All right? So I'm not preaching the Word of God to you, even though I hold it high. The bouncing of light waves when it strikes an object, reflection. So everything that you're seeing in this room is reflected off an object. So, you know, we have the little fun house. This is when Sam and his family was at Palisades Park, the fun house. And what we want as a pastor is somebody that holds up the Word of God and lightens us. And we want the light to shine to reflect Jesus. And when there's no light, there's darkness. We can say what we want about America. When I say most of the darkness we're having is because people have rejected the Word of God. Absorption. So you do this. You need sunlight to activate the vitamin D in your body. So here's somebody that, ouch. And we only see it because the sandals, are covering the skin, and here's somebody that. By the way, how observant are you? I think she was sitting at a ball game, and I see the fence behind her. Do you see that fence behind her? People on the other side of the fence. And she paid a fee to come in here. There are stands over here and stands over there. All right? Have you been to the ball fields where there's 4 or 5 or 6 ball fields? I remember one time, one nephew was pitching on this field. I could watch him pitch and turn this way, and my other nephew was batting on this field. By the way, all 5 of those nephews were playing that day. But the interesting one to me is refraction. If it wasn't for refraction and the properties of light, you could not see. When God created light, He created it for the entire world, for the entire years that we're going to have on earth, to be used in photosynthesis, vision, and so on and so on and so on and so on, perfectly in day one. So what is refraction? Refraction is the bending of light when it passes through something. Okay, it passes through glass, it is refracted. So to illustrate this, I'm going to go back to an illustration I used before. Most of you don't realize Nat was an excellent cross-country and track star. He was at What's the Matter You. Pam also attended What's the Matter You. She was a cheerleader. So Nat, when he's out running, there is sound with that. So you know what a cross-country course is, right? It will go through fields and so on. There are some cross-country courses where they might have a stream or something like that. I think that's called steeplechase when you do it in the Olympics, right? So here's Pam waiting for her boyfriend to come running across the stream. And when he's running, he can keep a certain pace. But when he hits the stream, what's going to happen? It's going to slow down. He might dive in.
Let it be.
So she's humming as she's waiting for him.
Whisper words of wisdom. Let it be.
Be, ba-dum-bum. And she's got her insect repellent out there. Along comes Nat. He reaches that water. He slows down as he goes across it. And then he speeds up as he goes on the other side of it. And of course, she wishes him good luck. Honey. Pa-dum-bum. Where's my pa-dum-bum? I always had a kid in the front row that would do that with pencils. Now, Nat's ability at What's the Matter You translated to what he was going to do afterwards. By the way, I'd have kids in chemistry class. When am I ever going to use chemistry? But his passion in college translated to his job later. And I would answer those kids when they say, when will I ever use chemistry? I would say, you never will. Learn this. Would you like fries with that, sir? So, as Nat got his job and started delivering the mail, and by the way, do you recognize the buildings in the background there? That's Cary Quad. And there's the Union. And there's the Bank One building. And by the way, there's a picture, I think like 30 years ago. And this building right here has had 50 different businesses in there over the years. And now you can see the buildings in the background there, the skyscrapers. What, 12 stories? And, you know, he had all kinds of delivery places where he needed to deliver the mail. And by the way, I looked this up because I knew who number 11 was. Do you know who that is? It's PJ's brother, Isaiah, who just finished his last game a week ago. And Purdue beat number 8 Michigan State 71-42. Now, what can we conclude from all this? Well, we can conclude this. If Dan Clark asks you to take your pictures, you should say no. So, refraction, the bending of light when it passes through something. Now, all analogies fall apart somewhere, but the analogy is still valid. So here we're going to have air, glass, and air, and a light wave coming at it. By the way, I asked a student in my class whose dad was a physicist at Argonne National Laboratory, I said, ask your dad tonight, is light a wave or a particle? You know what he came back with? A wavicle. Sometimes it acts like a wave, sometimes it acts like a particle. See, we don't create light. All we do is study the properties and uses of light. So here comes the light wave in, and I think there are sound effects that go with this. Since it is hitting the pane of glass straight on, it is not, I mean, it's refracted, but we don't notice anything about it. Here's when it becomes interesting. When it comes in at an angle, they tell us in physics class, draw a normal that's a perpendicular to the surface. Draw a normal, and when it slows down, the light wave is refracted or bent toward the normal. All right? By the way, I see some of you shaking your heads, none of you taking notes. This is going to be on the test. So just a word to the wise. And when it exits, it speeds up, so it is bent away from the normal. And there is a physical example. You're mowing along, you come to a sidewalk, and this wheel, because it hits the grass, is resisted, so it slows down a little bit. And this wheel, because it's still on the concrete or sidewalk, keeps the speed, so it is bent. All right? So let's see if this works. Here's an example of refraction. Of course, your kids never left anything in the yard, right? I started teaching in the 70s, finished in the 2000s. Kids nowadays like violent stuff. And I think you fall into the same deal as that. So here's a prism. I didn't say prison, I said prism. You're in prison, you'll get out in 20 minutes. So here comes a light wave in. There's the normal. Is it bent toward or away from the normal? It is bent toward the normal because it slows down. Here it's going to exit. Is it bent away or toward the normal? Okay? So here's what happens with the prism and sunlight. And this is some of what Newton was doing with his experiments. Now, The EM spectrum, electromagnetic spectrum, is not just what we see. What we see is a tiny part of the entire electromagnetic spectrum. And here it is. You see long radio waves to the right, AM and FM, microwave, infrared, then the visible spectrum, which our eyes can see, then UV, X-rays, and gamma rays. By the way, it's a very good thing that your eyes do not perceive and observe the other waves. How many AM stations are there? How many FM stations are there? All those waves are hitting your eye right now. Would you be able to see if you could perceive all those others? Absolutely not. You would not be able to. Now, there's the visible spectrum. Red, orange, yellow, green, blue, indigo, violet. This is an excellent book. I don't have time, and you don't have the background for me to discuss the absorption of the atmosphere of the radiation, where the only thing that gets through is that visible part. God created light and the earth so that they match each other perfectly. It's not an accident. Here's what's absorbed by water. Do you understand? If that was not available to go through, we wouldn't see anything on the earth. So here they are. Red, orange, yellow, green, blue, indigo, violet. I know we don't talk about indigo much, but what we want is Roy G. Biv, not Roy G. Biv. And who is that? Well, here's the question. I actually looked up Roy on Google. Is it Roy G. Biv? Is it Roy Orbison? Roy Rogers? Roy Lichtenstein? Or none of the above? Cast your vote. It's not Lichtenstein. There weren't that many Roys. I looked at him and I go, I don't know who that is. It's not Roy G. Biv. It's not Roy Orbison. It's Roy Rogers. There's sound there. Happy trip. I'm going back.
Happy trails to you.
How many saw him on TV? See, the kids, they had no idea. And by the way, Roy Rogers and Dale Evans proclaimed to be Christians, and I think they were. I don't think Trigger was a Christian. So here's what happens with a prism. Prism.
A ray of light is made up of the same 7 colors seen in a rainbow. This is seen when a ray of light is shone at an angle through a prism, a triangular-shaped piece of glass. Light slows down as it goes from air to glass and causes the ray of light to bend. This is called refraction. Each color in a ray is bent at a different angle, allowing 7 colors to be seen. The red light gets bent the least, while the violet light bends the most. Sunlight, therefore, is key to the science of rainbows. Light travels more slowly through water than air, so that raindrops act as prisms, bending, separating, and reflecting the light that shines through them. We can see a rainbow because the separated light is reflected toward our eyes.
Nice. Double rainbow. By the way, a real rainbow, if you're flying, a real rainbow is what? A complete circle. Let's take a look at refraction.
We need light to see the world around us. But do you know that light can also play tricks on our eyes? If you look across a dry road on a hot day, you may see a wet spot called a mirage. Look, there it is. This man is quite tall. But hey, he shrunk when he got into the pool. See how his legs seem shorter now? Look carefully at the cup across this hot stove. See how it seems to be shimmering? These two kitchen sinks are of the same depth, but the one on the left is filled with water. It looks shallower too, doesn't it? Is the print too small to read? See how a magnifying glass helps. There is something hiding in the cup. What do you think it is? Oh, it's a coin. This is an ordinary pen, but notice how it seems to bend at the water surface. What causes all these visual tricks or phenomena? The answer lies in an interesting behavior of light, refraction. We can demonstrate refraction by shining a beam of light into the container of water at an angle. See how the light bends as it enters and leaves the container. We call this bending refraction.
So I claimed God created light in our eyes so that we could see. How is that? Let's take a prism, a pane of glass, and another prism, and put them together like this. That's how it works. Look at that. A drop of water. It's inverting the image, isn't it? Of course, here we're violating gravity. Inverts the image. Refraction. If you're using a bow and arrow or a spear, you better not aim directly at the fish. You'll miss them every time. Now, just a little break here. Are these the first steps on earth? The very first steps. Of course, we don't believe that anything walked out of the ocean. We do not believe that. I don't believe it. You might. So, in your eye is a lens. It takes those rays of light that are coming in, focus them back on the retina. If you need glasses, there's something wrong with the shape of your eye, that they need to be focused before or later than what they are naturally. Actually, that image on your eye that's being formed right now is upside down. Your brain, somewhere between the optic nerve and the brain, somehow it flips it right side up. The speed of light. This is incredible. And I've studied the speed of light. If light could travel around the earth, how long would it take? Oh, wait. Wait, you people don't believe in science, do you? Sorry. I believe in science. I don't believe in false science. Let's see what you think. 1 hour, 10 minutes, 30 seconds, 1 day, or none of the above. Have you voted? Not 10 minutes. It's not an hour. It's not a day. It's not 30 seconds. The speed of light is incredible. Light travels 186,282 miles per second. That's fast. Through a vacuum. It slows down through air slightly, and it slows down through glass or water. 2/3 that speed when it goes through glass. So here we have the Earth, and let's see what it takes. There was sound there too. And I calculated the radius that it would project up here and did a calculation. We scientists like to do that kind of stuff. And I calculated what I showed you as it went around. 0.033 miles per second. This animation up here compared to the speed of light. By the way, here's what I showed you a couple of years ago, and I was doing the calculation. I go, that's wrong. Sorry, I need to put the 25,000 mile circumference of the Earth above and the speed of light underneath to come up with 0.134 seconds. If you could put mirrors around and have light travel in a circle. So when we study the properties of light, think of this. Light travels 93 million miles from the sun to the earth through nothing. I understand how you got here. You got in a car or a truck or some of you might have walked. I kind of understand a wave, going out on water. I kind of understand sound. How sound can go through the air. I'm sorry, my mind doesn't understand sunlight traveling through 93 million miles, landing on Earth, and it drives all the mechanisms that we know on Earth for thousands of years. I'm sorry, my mind can't get around that. I know it happens. Look at all the water cycle, the purification that we have of water because of the sun falling on it, evaporating it, condensing and coming down. I'm sorry, it just drives the mechanism of photosynthesis. You see, this thing didn't happen over millions of years. The sun was there, the plants were there, the animals were there in a short period of time. Everything working together. I may come back. I may circle back to that one, and I did when I talked about plants. This is totally cool. Total internal reflection. If light is traveling through some kind of an object like glass, or through something like a cable, and the angle is shallow enough, the light can be bounced back and be totally internally reflected, like this. Here, the light wave bent toward the normal, but it bounces off the water at the top. It's fiber optics. Most of you have, your home internet is fiber optics. Did you know that? Light traveling through something like glass. Fiber optics. You've had an operation. For a knee, they used to cut it open 8 or 10 inches on both sides. Talk to people that are in the 50s, 60s, 70s who've had that operation. Now they put 2 little pinholes. And what do? They look through some kind of a fiber optics to see what they're doing inside. It's amazing. Now, what operation is she doing here? It looks like the guy's head, maybe through his nose. I'm not sure. Not sure what she's doing. I'm not going to do this demonstration. You actually could do this at home. I have it set up, but we're not going to have time to do it.
So I have a green laser going through this tube of water. And the tube's releasing the water at an angle. The index of refraction of air is less than the index of refraction of the water. So this laser, as it's coming through, it bends towards the surface. But the angle is such.
So all that information that's coming to you is coming in little ones and zeros, and it's interpreted by your television set or your monitor. I don't know if you realize that, by the way, that's an actual fountain. And Carolyn's not here, but she did ask, Willie, do you like my hair? You don't have to worry. Willie took it as most husbands do, a competition. Looks fine to me. Once again, if Dan Clark asks if he can take your picture, your answer should be no. I think we're going to skip these questions. I'm going to jump ahead a little bit. I've got several questions there. 236 times in the Old Testament, the word light. 203 times in the New Testament. How many times in this presentation? 395. Oh, wait, you're not supposed to see that page. Jesus said to them, I am the light of the world. He who follows me will not walk in the darkness, but will have the light of life. You are the light of the world. A city set on a hill cannot be hidden. We're going to quickly ask this question. From what is this verse taken? Paul's physics lecture at UA, that was University of Athens. The Apocrypha, Mount Nebo, Sermon on the Mount, none of the above. What do you say? Sermon on the Mount. A city set on a hill cannot be hidden. Again, I got off on a rabbit trail here and started studying the Greek. I don't know anything about Greek. I know a little Greek. He runs a restaurant up on the west side. So I'm thinking, okay, was Jesus sitting there and talking about this and pointing to a city and saying, a city set on a hill cannot be hid? So here's a picture of the Sea of Galilee or Lake of Gennesaret. The Sermon on the Mount probably was here. I actually had to go to a, Earl would like this, Today's Catholic, and they said it was a certain place, so I started looking for that place. They said the city of Safad, here and here. So I actually got on my bicycle and rode along that trail to see if, and by the way, here's a woman in that area, and she's reading a Bible that's pretty marked up. Pretty cool. And I've come to the conclusion, no, but they probably knew about that city, but he couldn't point to it. There seems to be a barrier between those. So I think I'm going to go to this. Maybe, maybe not. And so I see my position or job as to extolling the Lord. Every day I will bless thee. I will praise thy name forever and ever. Great is the Lord and greatly to be praised, and his greatness is unsearchable. One generation shall praise thy works to another, and shall declare thy mighty acts. There is sound there. And of course, to us, the most incredible thing, light is incredible. You could spend the rest of your life studying it. This is what we think is incredible. And with that, I'm finished.